All right, well, hey, it is 2:01 UTC. Hey, everybody, this is Astronomy Daily Live for the 29th of July, 2018. And welcome. You can see that I've got a you have a slightly different view now, much wider field of view at least. Um, Yeah, so this is the new webcam. This is a Logitech C615. So there uh, went into one of the larger towns in my area, and there was a little bit of a choice between two. So like, all right, I'll get this one. So yeah, hopefully this will work out. It's I was expecting a much wider field of view, right? I mean, my old webcam was like I can sort of draw a box, right? Whoop, it was like, you know, like that, right? Just put my head in it. Now you guys are seeing like big chunk of the room here. You can now see over here. This is sort of my light source over here. And you know what? I'm going to turn me up before I forget. Turn me up, turn Bobby down. Speaking of Bobby, Bobby is on the panel. Hey, Bobby, what's happening?
Nothing much, Crossman. What about you?
Everything's good. Had a band meeting, I guess you can call it, today, and looking forward to moving ahead with that. Getting a little bit more action there, and might be bringing on a new person to add a little bit of new dimension to what has been going on. So we'll see where all that evolves. But yeah, I sort of like this wide field here. I'm gonna get my poor Linux machine turned off, or at least not playing the live stream. So it's looking pretty good. I'm watching it over on my smartphone, and it's looking pretty good over there. Hopefully, there isn't any incriminating uh, incriminating uh, things visible.
Yeah. And we got Uncle Bill Doran and Patrick Manning. So what's up?
Hey there, you guys. Patrick, haven't seen you in the chat in a little while, so nice to see you there. I'm gonna pull up the chat here too. Yeah, turn up my mic. Turn up my mic. Is this not? Is this not loud enough?
It's rounding up to me.
Okay. Yeah, I tested this earlier today, and it sounded okay to me too. So yeah. All right. Well, very cool. So yeah, this is just the new webcam. It really isn't high def or anything. I think it's still going to be coming at you at 720. Pretty sure. Pretty sure. So we'll see if little old laptop here can handle that. And yeah, I'm sort of digging the wider field of view. You know, you can see my some of my CD collection now, and more of the books. And I've see my little orange cloud up here. Yeah. Cool. Yeah. Okay. So 16 by 9, 720. That's cool. That's cool. So I've
Lunar
got the
eclipse.
regular. What's that, Bobby? Sorry.
I was wondering if we're going to look at those pics of those lunar eclipses again today.
Yeah. I just I thought that we would just go through. I was looking at Google Images, and they have a bunch of them there. So yeah, let's do that. Yeah, and Uncle Bill, I've got Bobby turned down pretty low, and I've got me turned all the way up on the control room for the live stream. So I think I'm about as good as I can get. Maybe Bobby can turn his mic down. I don't know if that's a possibility or not. So, but Bobby, maybe you can look into that a little bit. But you know, these kinds of things I don't worry about too much. I know that we want a nice viewing experience. So, oh yeah, and you can also see my window shade here of sorts. It's yeah, just a bunch of peace signs, but it's got a bunch of holes in it.
I'm wondering if I have my fan and stuff. I wonder if it's better now.
Yeah, I don't know. You sound okay to me. So, yeah, it's what the viewers are mentioning in terms of you being a little on the loud side. But for me, it's fine. Yeah. In fact, you're a little bit faint on my end. So, yeah. All right. Well, cool. Let's. So, yeah, I'm glad to have this slightly larger format. The cool thing is that if I want to, right, I can actually zoom in. Let's see. Watch. Here we go. Okay, so I can actually zoom into almost where I was, and in fact, I can go quite a bit more. Look at that. I can go all the way up there. So, but I think I'm going to keep it backed out all the way. I think that's fine, and it's sort of more like a porch then, right? With all of us sort of sitting around and yeah. Yeah, I think Patrick, as soon as I can, I'm gonna pull out the scope too, and maybe do a live stream showing off Mars. I think that'd be fun. So yeah. Oh, that's just Patrick. That's just some of the collection. It's just it's just a selection of music, mostly rock and roll. There's I sort of have them organized a little tiny bit. There's some Alan Parsons Project up here. There's some Yes over here. There's some Doors. I'm trying to remember. Pet Shop Boys down here. I think I've got some John Denver over here. Yeah, a whole bunch. So I've got another thing of about the same past over that way. And then I've got another one on this wall and over here. So yeah, I figured, why keep all those, boxed up in a container that I can never see? I want to, be able to see them all. So here we go. Cheers.
Yeah. Hey, I got a question for Patrick Manning. How's your RTL SCR treating you?
How about it, Patrick? Mhm. And I don't hear anything from Patrick. Mm. Well, we'll hook up at some point. No problem. Let's take a look at those out. What I did is I just went to Google Images and I'm going to share my screen. I can still do that. Let's see. Share the screen.
Patrick, the question I was asking you is, how is your RTL SDR doing?
How's your RTL SDR doing, Patrick? Okay, so let's do Lunar Eclipse ESE 2018. That's what I searched for before. And we just went to images. And there's quite a few. Still only FM stations, Patrick says.
Are you still mostly on the FM, or are you exploring everything else besides FM?
Uncle Bill is talking about viewing opportunities of the ISS. Very cool. Yeah, that's a periodic thing where we'll get some good views. Usually it's a case where we'll either get some good views at sunset or some good views at sunrise. So here we go. Here's some pretty good shots of the eclipse. Various shots. So it only gets FM.
Yep. Yeah, the RTL SDR is supposed to do more than just FM and stuff. I can understand there's no AM or shortwave, but try catching like satellites, the ISS, some police scanning and all that. Try that, Patrick. It's really great.
Yeah, cool. So here's a visibility map. So this is where it was visible. And you can see that just a pretty small portion of the globe didn't have any really good view of it. And that's this dark, right? So really it's just North America that missed out. A little bit of what is that? Northeastern Asia, and of course the whole North Polar region here wasn't able to see it. And then where it's all white, they were able to see the whole thing. So, half of Africa, Saudi Arabia, basically, the Middle East, India, Pakistan, Afghanistan. So, yeah, our instro is over there, right? So yeah, I'd like to know if that was visible from our instro's location. Maybe he or she will pop on and give us a report. So pretty cool. Just I would say probably about a third of the planet couldn't see it at all, but the rest of the planet got just sort of barely. Yeah, Patrick, if lunar eclipses didn't happen a couple times a year, I'd feel sort of the same way. But there's going to be another opportunity in 6 months. Don't exactly know when or where that's going to be visible. But yeah, there's a pretty good chance that we'll see some of it. Actually, the last one, right, prior to this, I think, didn't we see that one? And I think I live streamed it. So let's see, let's just go back here and see what else we got. So, you know, I think one of the most amazing views is a view that no human has ever seen yet. And that is the view from the moon. Okay, so if you were standing on the moon, looking back at the Earth during a lunar eclipse, what you would see is this big dark disk, right, which is the dark side of Earth, and all the way around it, all the way around, would be like this sunset red ring all the way around it. Just a spectacular view. I think, you know, what somebody should do, and here's, you know, if anybody in the space industry is listening, right? It's like set up a camera. Doesn't even have to be a video one. It could just be a regular old camera. Set it on the moon, right? Like, you know, anywhere here, right? Preferably sort of right in the middle, but it doesn't matter exactly where. And get a camera up there for an eclipse, and then during the eclipse, photograph it. You'll make millions and millions and millions of dollars off of one photograph. I mean, everybody will want one. So, okay. So, Stephen, hey, Stephen, nice to see you in the chat. I think you're new, so thanks for coming in. So January 19th. January 19th is the next one, and Stephen's saying that all of the U.S. is gonna see that one. So yeah, you know, we'll catch that one. We'll catch that one. Yeah, you know, Uncle Bill, that is the live stream that I watched, and that was absolutely fantastic. That was absolutely great. They did a great job. As I said, I think probably the most interesting thing for me was actually seeing that binary star going through. Anyway, these are all the great shots, great views of probably most of these were lunar eclipse from a couple days ago, because these things are saying, you know, 2 days ago, a day ago. So pretty cool. And it turns that red because of the atmosphere of the Earth. That's what makes it look all red like that. It must look just amazing from the moon. I can't wait to be able to see that kind of thing. All right, well, very cool. I thought that we would, let me go back to here, stop sharing, see how this wide field is starting to look as it's getting darker. Yeah, okay, that's not bad. Should I, gonna have to excuse this a little bit, but I'm gonna mess with the settings here a little bit. It's great to be able to mess with settings. Let me increase the gain a little bit. Oh, that's a little bit too much. Mess with the brightness a little bit. Yeah, that's not quite right. All right. Well, I'll leave it alone for now. Don't want to do too many experiments, because I am mindful of the time, and I'm dropping frames. Yeah, I am not surprised, Patrick. Not surprised. All right. Well, cool. Let's do a let's do a constellation of the day. Done one of those in a while. So what I'm going to do over on my Linux machine over here is pull up my list of constellations. Let's see, I've got to go to the right place to do that. I'm definitely not in the right place now. Got to go there, and I've got to go there. So I've got a list of the 88 constellations that the International Astronomical Union has designated, and I've got them in alphabetical order. So now let's go over to random.org. I'm going to share my screen again. And let's see, we'll go over to random.org. Oh, ORG. Yeah, okay. And we're going to have it choose an integer between 1 and 88. Ready? Here we go. 76. Okay, so I'm going to come over here and look at the 76th one. It is Serpens. Serpens is the constellation of the day. So let's take a look at Serpens. Now, Serpens is a northern hemisphere constellation. Let's try that again. That's going to hide that, and we're going to go Serpens. Oh, it's a bad typing day. Serpens constellation. And Wikipedia, good, some pretty good things to show there. Look at the constellation in the sky, etc. What's stellar objects we've got? Look how large it is or how small it is. We'll see. All right. Yeah, this is a relatively small constellation. Relatively small constellation. Look, it goes from a little bit more than 15 hours to a little bit more than 16 hours in right ascension. So that's about 15 degrees wide. It's a little, in terms of declination, though, it's a little bit more, right? It's almost 30 degrees high, right? It's going from about maybe -2 to about +20. Oh no, that's a 4, I guess. So -4 to about a +24 or so, something like that. And there it is. Now, most constellations, most of the stars in the constellations have multiple names. The visible ones were first named long ago, and they simply said, okay, the brightest one is going to be alpha, and the second brightest one is going to be beta, etc. And so, for the most part, constellations follow that rule. It's not a hard and fast rule, though. So sometimes that'll be the case, and sometimes it won't. And I'm sort of thinking in this case that it starts okay by following the rule, right? This bright star here is alpha. Beta is this one, and is it brighter than the other ones? Kind of hard to tell, right? The bigger the dot on these charts, the brighter the star it is. That's sort of how that goes. Beta, delta, gamma, epsilon, yeah, and it just goes on from there. There's actually, it looks like there's a bunch of taus. There's a tau 1, a tau 5, a tau 6, a tau 7. So I don't know what's going on there. And it looks, at least on this chart, that we have one interesting non-stellar object, and that's this globular cluster right here called M5, which is a very, very, very awesome and big globular cluster. We should maybe let's start to the HST archive and just see if they've got M5 observed that for a second or two. So let's see, we'll just choose everything, and we'll go M5. That search. I'm sure it's been observed. Be surprised if it isn't. Yeah. So apparently M5 is also NGC 5904. That's not too surprising. Come on. Let's see. So the most recent ones are 2014. So let's look at those first. 3 different wavelengths. Well, maybe we can even make a picture out of it. Let's see what it looks like here, huh? Yeah, there's M5. HST images are so great because the resolution is so good that you can see right down into the middle, and that's always very, very nice. So let's see here. This is 336. That's, I'm sort of looking here, right? 336, 438, and 275. So 275 is a shorter wavelength than 336, and both of those are a shorter wavelength of 438. All those are pretty much in the ultraviolet, though. But we can call this one blue, and this one red, and that one green, and see what we get. So this first one would be the green one. Let's just try this really quick for fun. We are doing astronomical things here. And it goes real fast and catches up. That's cool. Okay, so M5, one. You know what? Well, no. Let's do it like this. I don't want to call that green, just in case we want to change it. So let's grab this next one. Hopefully, it's in the same place. So everything is registered correctly. I assume it is. I guess we're going to find out. So this is M5002. And let's grab this third one. So different exposure times here. 612 for this one. 59 seconds for that one. And then 1378 for that one. And for some reason, they decided to do that one again at 1380 seconds, and that last one at 58 seconds as opposed to 59. I don't know. Did we get one? Oh yeah, we did. Wow, that's a pretty bright bright star there in the ultraviolet. kind of interesting. 5003.jpg. Oh, I don't have to do that part. Okay, so now let's go over to GIMP. I use GIMP mainly because I'm a cheapskate and I'm you know, both too poor and unwilling to pay for Photoshop. But GIMP is awesome. GIMP is really, really awesome. So I think people who use Photoshop and are used to Photoshop don't like GIMP. But I have no problem with Photoshop at all. I think it's awesome too. So GIMP is slow at loading, and it's even going to force the poor machine to work even harder than what it already is. But it'll slowly load here. We can actually go back to this. And all right, well, let's see just what Wikipedia has to say. We can also go to Burnham's Celestial Handbook, which is my for this kind of stuff. Let's see. So the brightest one, alpha, is a magnitude 2.63. And that's one of the cool things, you know, I don't really show off all that much, is that SIMBA astronomical database is not only for galaxies and clusters, but you can look up individual stars. This is the database of all things astronomical. Quickly do that too. It looks like Penis, is that what they called it? Serpentis. Serpentis. ENTIS. Alpha Sur, calling it a high proper motion star. That just means its apparent motion is large, which means it's moving fast relative to us.
Before we continue, you might want to like try to turn me down because I had to refresh because I got kicked out.
Well, that's not very nice. That's not very nice. Thanks for the reminder, though. I've got you turned down. There we go. So yeah, this thing is moving pretty quickly. Now these numbers here are in, I believe, milli-arcseconds per year. So that's thousandth of an arc second per year. So at least in right ascension, right, it's moving about a tenth of an arc second per year, which is you know, that may seem like a small amount, but that's actually cooking along pretty good, But its radial velocity is pretty low, so it's moving across our path, but it's not really moving like away from us or towards us at any serious speed. You know, 2.63 kilometers a second. Yeah, that's still fast, but not for astronomical things, for sure. But anyway, so yeah, you know, Simbad can be used to find out information about stars too. And as you can see, this star has a bunch of different names. Most stars in the constellations have a number. So this this star, its number is 24, and that usually the numbers, they start at 1 with the star that is furthest west in right ascension, so the lowest right ascension, and then those numbers increase as you move east. All right, let's try to load this. Let's try to load this guy. I'm going to put you down just for a second.
I don't know where the ladies are at, Patrick.
Yeah, they may not be here. I know. Atta was going on some kind of a tour, some kind of an acting tour. She said like eight days, but I don't know how long ago that was. This machine likes to do things load it one at a time. So we'll just do it one at a time. We can do that. We'll just open up 3 different layers. And then we'll see what it looks like. I need a thread ripper. I don't know what a thread ripper is, Patrick. Tell me. I'm going to invert that. Looking better already. I'm going to invert that one. You won't see any difference. And I'm going to invert this one. We can actually look at each one of these if you wish. Let's do that. So there's that one. And there's that one. Yeah, I don't think they're going to be quite stacked on top of one another. Especially that one. That one doesn't look right at all. Well, let's try it anyway.
A bit different.
Yeah, it really does. We'll play with it a little bit here, see what happens. So what I'm going for is I want to look here again. So the first one is going to be the green one. Okay, so let's make this green. Oh, we got to RGB it. There we go. Okay, so now let's try to.
Like RGB them all or just one?
I'm going to RGB them all, but in different ways. So this one I'm going to make. This one I'm going to make green. I just grabbed the wrong thing. So let's make this like a nice bright green. Come on. And I'm going to saturate. So that's almost a lime green. Okay. So make that one green. The second one is our red one. Okay, now these aren't actually red, right? These wavelengths are all in the ultraviolet. I'm just sort of arbitrarily picking colors, saying I want this short wavelength one to be blue, this long one to be red, and that one in between them to be green. So I'm sort of arbitrarily choosing these. So the second one wants to be red. So we'll make him red. I think is red. Yeah, red's down there. Making a nice bright red. We're not going to see these yet. I sort of didn't do this in the same order that I normally do them. So there's almost blue. Let's look at a nice blue there. There we go. Okay, so now I need to combine these, and there's a bunch of different ways to do it, but what I start with is this thing called screen, whatever that's called. And yeah, it looks like they're not going to be aligned. But we can mess with that maybe a little tiny bit. I don't want to dive into this too much. Oh yeah, they're very misaligned. But we might be able to fix that. Let's zoom in here and sort of see where we are. So I'm going to come over here and choose that thing. And then I'm going to move these around. Oh, it's going to be really hard to see though. So that's the red one. Can we line up the red and the green? Is that possible? Oh, I need to select that one again. That's pretty hard. Wow, that's pretty hard to do. There's just all the red. So let's select that, and I think I want to try to key off of that bright star if we can find it. Zoom out a little bit. Is it that one? Is it this one that we're trying to line up on? I don't know. Let's find out. Let's scooch this guy way over here and scoot him down. I don't know. Is there an alignment there? It sort of looks like there is an alignment there. Yeah, I think there is.
Looks like you did had it.
Yeah, I think that's it.
Yeah.
Let's zoom in a little bit more and just mess around here a little bit and see. Oh yeah, I think we're there. Okay, so let's do that. Let's stick the blue in there and just see where that is. Ooh, okay. Well, okay, is that the bright blue one there? Yeah. Let's zoom out a little bit, make sure. Yeah. So let's do that, and then we'll do that. And now we know that we need to move this blue thing over to here. And that should line all of them up. Something like that.
Wonderful.
Let's see what we've got here.
Much better.
Yeah, definitely not my my favorite color scheme. for sure. Okay, all right. Threadripper, 16-core processor. Jeez. Yeah, well, I don't know what this one is, but you know, maybe there's half a core left in this one. So, okay, well, interesting enough. I'm not going to belabor this too much. I'm just going to save it and come back to it at some point in the future. Maybe I'll export it too, and maybe post it over on the Discord server as is. We'll see. It's definitely not really even all that good, but it is what it is, I guess. What is this thing doing? Oh, it's working hard. Trying to write out a PNG file. It's always a challenge. But let's get back over to Serpens, see what else. I think what I'm going to do is I'm going to stop sharing for a minute, and I want to remember it's over on the shelf back there. All right, hold on one sec. I'm going to get Burnham's. Hold on. Yeah, I'm going to have to work on this bright light over here. That's kind of annoying. Going to have to do something else with that. So I've got, now this is volume 3 of Burnham's Celestial Handbook. And this is probably well, I mean, all the contents are there, but it has no front cover, it has no side, and it has no back at all. And yeah, there's like coffee or something spilled on this. I don't know what. So, but all the contents are there. So let's go over to Serpens and see what Burnham's has to say about Serpens. Bunch of binary stars. Here's the first page of binary stars, and this thing will autofocus now. So watch this. Oh, is it going to? There we go. So you can actually see the entries there. These are binary stars in Serpens, and you can see all the information that they provide, you know, the basic information there. So that's page 1. So that goes on for a couple more pages, right? They're all binary stars. So, you know, if you're into binary stars and have a relatively decent telescope, where you can magnify, you know, maybe like 100 times or so, you should be able to see most of these binary stars, most of them at least. And, you know, there's quite a few there. So that is quite a project. There's a bunch of variable stars. Here's all the variable stars. I'm going to come over here. You can see those too. Oh, I like that focus. You can see all the variable stars. Sorry about the lighting. And it looks like, to that last entry, what does that say? Nova 1970. So that's a star that went boom a little bit. Not a supernova, not incredibly explosive, but certainly some kind of exciting event there. So this thing should autofocus back if it hasn't already. I think it is. And then here's the non-stellar objects over on this page. And you can see, we'll zoom in again here. So M5 at the top, globular cluster, and then a bunch of galaxies and a couple other globular clusters. There's an open cluster. There's a planetary nebula. What's that say? M16? M16 is in, oh, M16 is in Serpens? Really? I guess so. You know what M16 is, right? You don't know what M16 is. We should look at that really quick like. You will know right away. So let's see. I'm going to share my screen again, and we'll look at M16. I think I'm thinking of the right one. I think I am. Guess we're going to find out. Let's see. How should we do this? Let's just do it through Simbad. I believe M16 is also called the Eagle Nebula, or is that MC? That's where I'm getting confused. Okay, yeah. Okay, well, I guess M16 is the cluster inside of the nebula. All right, my bad. But let's see if the Sloan Digital Sky Survey, is it seeing this thing or not? Doesn't look like it is. Anyway, this is the location of the famous pillars of creation. We'll take a quick look here like this. And maybe HST will actually show it better than this. Idea. Yeah, there it is. So here are the pillars of creation, and here, of course, is the rest of the nebula. The stars in here you can barely see, but that's actually the cluster that they're calling M16. And the idea is stars in this big cloud of dust and gas. All those stars are making this gas and dust glow. So there's a little bit of reflection and a lot of emission. So very, very cool place. Now I can be pretty certain too that HST has this one. So probably the most famous HST images ever taken, but there's probably a lot of observations. Yeah, 220. A lot of people have been looking at this for quite a long time. Let's see what we've got here. some recent stuff which probably isn't available for us to view. Yeah, not available. Most astronomical data uh, is sort of owned by the people who do the observations for 6 months or a year or so, and then it becomes publicly available. So my guess is that all of these probably aren't available yet, but these ones in 2014 might just be. So these are images in the infrared. You can see the central wavelength here is in angstroms. So that's 15,000 angstroms. That's quite red. And hard to know exactly what they're looking at here, but there's a little bit of nebulosity here. So they're looking at a region that's sort of in the area. Here's some ultraviolet images. Ultraviolet? No, I wouldn't say that's ultraviolet. That's pretty red still. Oh, there we go. Wow. I don't know if I've ever seen those before. That kind of looks cool, huh? Oh. Yeah, I don't think I've ever seen that kind of detail before. That's pretty nice. Gas and dust getting together, doing their thing. Pretty intense, though. Isn't that cool? I don't think I've ever seen that. Let's see. So that's a 1200 second exposure. Looking in the red. I mean, things don't really seem to change. Still pretty cool looking, though. And those little blobs. All that stuff. That's pretty nice. I don't think I've ever seen these like this before. Let's just do a simple thing. Grab this one, and I'm just going to reverse it all. I'm going to save it, and then I'm going to reverse it. That's all I'm going to do to that. We can just save it just like that. Okay, so let's get out of this one. Close it all up. We'll open this guy. Here we go. Should open up. Yeah, so let's make sure it's in RGB mode, and then let's just inverse this and see what it looks like. There we go. Okay, so that's probably one of the famous images. That's pretty cool. It's nice to see it up close, though, like that. Pretty interesting things going on there. As you can see, a little bit of funkiness from the detector itself. These are things that the public usually doesn't see. They come in here and they clean all that up. But yeah, it's pretty nice. Pretty nice. We can actually even, because we've got a little bit of control here, we can play a little bit with the brightness and contrast. See if there's anything interesting with that. Goose up the brightness a little bit, goose up the contrast. Okay, well, I'm not seeing anything too exciting there. That's just a little bit of fun to see if there's anything interesting at sort of lower levels. But yeah, I'm not seeing anything too incredibly exciting. It's all, look at this blob here. It's all very, very cool, of course. Yeah, nice. Let's look at the whole thing, huh? Yeah. Undo that. Pretty nice. So yeah, I'd forgotten that that was in Serpens. So thanks to Burnham's, we got to actually go grab this really famous famous data set. That's always very cool. So let's see what else Burnham's has to say. The cool thing about Burnham's, right, is that they talk about a lot of the stars. You know, they'll talk about some of the history, right? I like that focus. Some of the history of the stars, and you know, they'll talk about a lot of the brighter ones. If there's any interesting variable stars, they'll show little plots showing how these stars vary in brightness. So that's very cool. I like that focus. Yeah.
Yeah, very nice focus indeed.
Yeah. So when I guess this guy, yeah, see, so here's a variable star that in the top panel, you can't really see it at all because it's so faint. But in the bottom panel, you can see it brightens up pretty substantially. So that's cool. Which variable star is that? That's R. R Serpentis. R Serpentis. There's also a W Serpentis, which is a variable star. Is this but it's kind of a irregular one, right? So instead of a nice, you know, sinusoidal one like R was, and look at this one. So that's kind of funky looking. There's something interesting going on there. Don't know what. Let's see. More of those. There's M5. There's a see. So here's an image of M5 from the ground, right? And you can see that the center of that is all washed out, right? It's just overexposed. Come on, I want you to focus. There you go. Can't really see the central core. Can't see that really bright star or anything, right? It's just washed out. So that's why, you know, in a lot of cases, having an HST image is so much better, you know, because you can see all the individual stars in there. But M5, which I didn't talk a lot about, that is a great telescope object, small telescope object. It's bright, it's big, it's easy to find. It's really easy to find. So I highly recommend you taking a look at that. So here's probably the best that Burnham's can do on that. And as you can see, it's pale in comparison to the HST image. Although this isn't too bad, not too bad. A great if you want to get into astrophotography, M16 is definitely a worthwhile and challenging target for sure. Oh, it looks like there's some interacting galaxies. I wonder if HST has looked at these. Should we look? It's NGC 6027. Let's go look. Let me share my screen again. Now, the probability of this, I gotta say, is going to be pretty low. But let's look anyway. Let's see. I'm going to close that, and I don't care about that. So what? 6027. So let's go over here. We'll go back to the search. NGC 6027. Now, chances are pretty slim, but we can see this cluster of galaxies. That'd be kind of cool with the HST. Ooh, we do. I like surprises. Now, it hasn't been observed in quite a while, but again, they're looking at it at 3 different wavelengths here. Green, very, very blue, and very, very red. So, wow, this, yeah, well, let's take a look at them. That is sweet. Oh, that's cool. Oh, man. I think I'm going to have to try to combine these two. It's just too much fun. So let's do that. So I'm going to save this as NGC 6027001. These are just the JPEG images, right? I mean, I'm not even taking the raw data. I'm just doing a quick grab. I mean, ideally, I would want to grab, the FITS data, the actual scientific data. These images here are, JPEG, so they're compressed. They're, who knows what. NGC 6027001. Oh, 002. That's quite a bit fainter, and I guess probably just because they're looking so far into the ultraviolets. See, they even goosed up the exposure time, to more than twice as long as blue and red and green. So, I'm sorry, red and green. But still, pretty faint. So not a lot of blue, right? Not a lot of blue. Okay, let's grab this last one. We'll take a look at it first. So this is the red. Okay. Probably what's going to happen here is we're going to get a lot of overexposure. So I'm not expecting much here, but yeah, we'll look anyway. Got to have a sense of adventure when you get into science. Got to explore things, even if they, end up at a dead end. Got to go for it. You got to be curious. Is that going to load just one, or is it going to load all 3? I'm going to try to load all 3. Hold on. Oh. No, I missed it. All right, so there's the first one. Just going to do one at a time. There's 2. Oh, well, that's kind of cool about Cow Sky. I'm going to add number 3. Okay, so I'm going to go basically through the same procedure, right? We're going to turn this into an RGB. and then we're going to inverse them all. So do that. And this one. And yeah, we can sort of see what that looks like. Okay, so want to go back to the HST image, and so it's green, blue, red. That's what we're going to do. Okay, so one is going to be green. So just doing the same thing again, same thing over that we did before. Real simple. So what did I say? Green, blue, red? Yeah. So this one's going to be blue. I think blue's up here somewhere. Oh. That's a pretty nice blue. Again, these colors are sort of arbitrary, right? You can choose whatever color you want. I'm more or less choosing these colors because they are going to represent what they would sort of look like to our eyes if we could actually see them. Okay, so now I'm going to go over here and do a screen and a screen. Yeah, so they're pretty overexposed. Not too surprised at that. And it sort of looks like, for some reason, the blue is really washing everything else out. Although it's the faintest one. So there's just red and green. Lots of interesting things down here. Do you see that? We got some. Looks like we've got some red galaxies down here. Looks like the alignment isn't quite right. You see that?
I guess without the blue is usually quite all right.
Yeah. Let's see if we can scoot that green over a little bit. There we go. See how it's. I'll try to line them up, but then see this. These stars aren't really lined up. So yeah, there might have a more complicated process here to line everything up. There might be some rotation that's going to have to take place and all that. So let's look at the. Here's blue and red. So lots of little red faint galaxies out here. Do you see how they're all red? And here's blue and green. Pretty nice little cluster though. Pretty cool. And this cluster is also in the constellation of Serpens. Look at this one. It's maybe it's having some trouble. I don't need to go that far, I guess. So there's that one all together. Kind of cool. We'll save that one too. Maybe look at it sometime in the future. Maybe not. Dun, 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 dun. Is it going to do it? I guess it's going to do it. Poor little machine. All right. Anything else interesting in Serpens? Doesn't look like it. Let's go over to. Oh, well, let's let this guy finish. You gonna finish? Let's see if Wikipedia has anything else to say about Serpens. Of course, Serpens is a It's a snake. I think Serpens has. I want to say that Serpens has 2 sections. Oh, I forgot about that. Yeah, look, cover that really quick. Serpens is actually in represents two different constellations with a constellation in between them. So Ophiuchus is this dude here, and he's holding on to the serpent. So you have this part of the serpent, which is the head, and this part of the serpent, which is the tail. And we actually see both. I focused on the head, but there's also the tail here too. Totally forgot about that. And that's where M16 is. Okay. That's why it wasn't marked there before, because it just wasn't there, but there it is. There's M16 right there. Cool. And as you can see, Ophiuchus is right in between. Just above Sagittarius. Yep. Just above. Yeah, okay. So yeah, there's Serpens cauda and there's Serpens kaput. So sort of a split constellation. So wow, there's a whole bunch of things here. There is the Red Square Nebula. Never heard of that. One of the few objects in astronomy to take on a square shape. Huh. Should we look at that really quick? Let's see. Red Square Nebula. Okay. Huh. Interesting. I'll have to poke into that a little bit. Find out if there's any other interesting info about that one. All right. Well, you know, I think for now, I think I'm going to exit these waters, let you all loose onto the world, get back to the astronomical world for another day. I think this camera looks like it's going to work out pretty well. As I said, I think I want to work on this bright area here that's kind of annoying, and I notice that I'm dropping out a lot. So I guess we got a bit too. All right, well, very cool. I'm going to get out of here for now. So I will see you again in a little less than 23 hours from now. Talk more astronomy for sure. All right, so take care, everybody, and I will see you on the spin. All right, bye-bye.
Later.